In this video, we are going to be doing 5 examples of factorizing by taking out a highest common factor. If you're feeling quite confident with this section, I would suggest maybe pause and try the sums first, and then we can mark it together. Let's look at number 1. So I like to just underline to see, okay, I've got my 2 separate terms, and I need to see if they have a common factor between the two of them. I look at my numbers first, at my 6 and my 8, and what is the common factor of 6 and 8? That must be 2. So I take out 2 as my common factor. Then I'm going to look at my variables, add my a and my a. There, I'm going to take out a squared as a common factor. Let's just break that down. So for the first term, a is being multiplied by itself 3 times. And for the second term, a is being multiplied by itself twice. So I can take out 2 a's there, and I can take out 2 a's there. So my highest common factor there would be a squared. And then my leftovers. So it's like saying, and it is important to understand these basics. Maybe you already know what the answer is, and that's fine. But we do need to remember and take note of what we're actually doing. We take the first term and we divide it by the common factor to get that remainder. So 6 divided by 2 would be 3, and there we would have an a left. So there's the remainder of the first term. And then for the second term, that would be 8a squared, and we are dividing that by the common factor, and that would give us 4. And there we go. How can we check if we're correct? So if we multiply it back out, let's see. That would give us 6a to the power of 3 minus 8a squared. And is it the same as where we started? Yes, it is. Then we know that we are correct. All right, let's look at the second one. So for number 2, again, I've got 2 separate terms there. And we need to go take out the highest common factor. For the numbers, we don't have a highest common factor there, but both terms has got that x that we can take out as a common factor. So let's take out x, and then the remainder will go into a set of brackets. So for the first term, we'll be left with 2y squared. And for the second term, I find that a lot of students say there's nothing left because there's an x that we took out. And that is understanding this idea also of what we are doing. We take the second term and we divide it by the common factor. And when we do that, it's 1. So we will have a remainder of 1. And remember, we also have that coefficient, that imaginary coefficient of 1 there. And let's do a check and see if we are correct. If we multiply it back out, let's see if we get back to where we started. There, and we do. So that means that we are correct. Let's look at the third one. How is the third one different? Well, the third one just has 3 terms. So there we've got 3 terms, which is perfectly fine. Now we just need to make sure that the highest common factor that we take out, we can take it out from all the terms. So all 3 terms. So if we are considering our numbers there, between 4 and 12 and 8, 4 must be our highest common factor. If we look at our variables for x, what can we take out there? We can only take out an x to the power of 1 because the middle term has got only one x. For our y, our base y, there we go. Consider all of them and we look at the middle term, it also only has that one y that we can take out as a common factor. So we use the lowest exponent. Then the remainder goes into a set of brackets. What will be left in the first term? Well, remember, it's like saying this. There's our first term, and we divide it by the common factor. We'll be left with x squared y. For the second term, 12 divided by 4 will be 3, and the x and the y will cancel out. For the last term, 8 divided by 4 will be 2, and then x squared divided by x, there will be an x left, and there will be y squared left. Let's see if we're correct. If we multiply it back out, let's see what we get. Then we get 4x to the power of 3, y squared, plus 12xy, and subtract 8x squared y to the power of 3. And is it the same? Yes, it is exactly the same. And then we know that we are correct. Because every now and again we make a silly error. So then it's just good to check. Now, example 3 and 4. Let's have a look at these two. There is term 1, and there we've got term 2. Now, I know what students like to do, or many of you. You just kind of go off on your own tangent and you start simplifying. You start multiplying that in, and then you get there, and then you start simplifying. We're not asked to simplify. We are supposed to factorize. So we're only considering our methods of factorization. And I'm sure you've already noticed, if we investigate and just see what's going on over there, we've got a bracket in both terms that is exactly the same. So in this case, our common factor is just a bracket. So then we take out that bracket as our common factor. Make sure that you keep it in its bracket because it is a common bracket. And then what will be left in the first term? Well, if we take that whole first term and we divide it by the common factor, then we will be left with 2x. And in the second term, we will be left with that. And there we go. We took out a common factor, we took out a common factor, which in this case is a common bracket. Okay, number 5. Let's have a look. Don't be tempted to start multiplying the 5x in. Then you are simplifying. You are supposed to be factorizing. So we notice that there are 2 different terms. So we need to see if there is a common factor between those 2 terms. Well, the brackets are exactly the same, so we can take that out as a common factor. I put this example in there, grade 10s, because we need to just take note that in front there's another common factor there that we can also take out. So yes, we're going to take out our y minus 2 as a common factor. There is our common bracket. But we can also take out a 5 as a common factor because 5 can divide into 5 and into 10. So don't forget to look at the coefficient as well and see what we can take out there. So our remainder would then go into the second set of brackets. If we take 5x and y minus 2 and we divide that by the common factor, then we're just going to be left with x in the first term. And in the second term, what are we going to be left with over there? Well, it will be 10 divided by 5, which will just give us 2. So watch out for your common factors. Watch out for your common brackets. And when you see common brackets, just make sure that it is in fact the highest common factor and that there isn't also something else that you can take out. In the next video, we are going to be looking at a common bracket, but we first have to do a sign change before the brackets are exactly the same.